All right. Hello, everyone, and thank you for joining us for week 4 of the Concentrator Talk, brought to you by the Oxygen Alliance. My name is Maui Lungu, and I'm currently in Lilongwe, Malawi, and I'm pleased to be hosting the Concentrator Talk today. So joining me are my colleagues, Timothy Mtonga, Jerry Douglas, and Amaprit Rai. We'll be here every week at this time to answer your questions and about concentrators and concentrator repairs. So remember that you can always send questions by email to info@oxygenalliance.org, and we will do our best to respond during the next concentrator talk session. So if you have any questions that you would like to ask right now during the session, you can type them into the chat and we will do our best to respond to them. So just a reminder to everyone that we advise you to keep your videos turned off and your microphones muted unless you are asking a question. So again, with me are several technicians today joining us. So we have Paulina Muhosho joining us from Johannesburg, South Africa. We have Georgie Kwanga and Mteto Sinjani from Lilongwe, Malawi. And we also have Sharon Ngozo and Francis Sambani, who are our crew chiefs for the OpenO2 mobile workshops. So just like we did last week, we'll have the topic of general interest, which is how to adjust the pressure regulator on different models of oxygen concentrators. So this will come along as we go with the questions. So we also have polls at the end of some of the questions, so please attend to them when they pop up. And if you can't see where to find the polls, just go to the bottom right of your screen and expand the activities menu, and you should be able to find the polls menu from there. And just a quick reminder to all of us, please remember to submit your contact details in the chat so we can add them to the mailing list, and let us know what country you are joining from. So as usual, I will read out the questions and ask one of our technicians to respond to the question. So we'll also paste the questions in the chat area in case you didn't hear it fully. All right, so moving on to the questions now. The first question says, how do I identify the medical grade zeolites from the industrial one? So I'll ask Georgie Kwanga to please take this one up.
Thank you. Indeed, there are several types of zeolite, the main categories being natural and synthetic. Despite having different variation of zeolite, each has a special application. Think of it as a fertilizer that is applied in the farm, where you also have organic and synthetic. Fertilizer may physically look the same, but has a different application. D compound and super D fertilizer look the same, but they have different application. Therefore, you cannot identify zeolite just by looking at it only. The one that is used in concentrator falls under synthetic type, and it has some of the following physical properties: 0.4 to 0.8 millimeter in diameter, nitrogen adsorption capacity of 23 milliliter per gram, nominal pore diameter of 10 angstroms, bag density of 630 grams per liter. So to answer this question, you need the data sheet from the manufacturer to guide you. Thank you.
Thank you very much, George. So if we have any extra comments from the technicians, the floor is open. If we have no additional comments, Jerry, can you please open up the first poll of the day?
Thanks, Maui. So I'd like to know, have you ever changed zeolite in sieve beds before? leave the poll open for a few seconds. All right, just give you 5 more seconds and we'll close the poll. All right, so it looks like we have 2 people who have changed Zeolite and 1 person who has not. Thank you.
Thank you, Jerry. All right, so moving on to the second question now. We have recently encountered an issue with one CANTA V8 concentrator. The concentrator recorded very low readings, about 42%. We replaced the zeolites. However, now the solenoid valve is not able to open up well, causing the compressor to almost shut down due to occlusion of the outlet. We have replaced the compressor maintenance kits as well as the safety valve. We replaced the solenoid valve with the new one. Problems still persist. The voltage supply of the solenoid valves was measured to be 7 to 8 volts on the board instead of 12 volts needed by the solenoid valves. Now we are yet to exchange the main board from the V8 concentrator to confirm the board issue. Has anyone experienced this issue before? I think we had this question in the previous session, so hopefully we'll be able to answer you. So Teto, can you please take this one up?
All right, so just going back to the main components of an oxygen concentrator, there are 2 types of main valve technologies because people mistake the 2. So there's the solenoid valve commonly found in Airseps, CANTA, and Longfal. And then there's a rotary valve only found in Devilbiss concentrators, both the 525 and some models of 515. So in order to identify a rotary valve, it has a stepper motor. All the valves perform the same task of feeding the compressed air to the sieve beds, wasting and purging air from the sieve beds, and equalization between the 2 sieve beds. So the issue you are experiencing is not common, but the following is a good step-by-step troubleshooting procedure. So first thing to note is that a CANTA V8 concentrator comes in 2 configurations. There's a dual flow meter, 8 liters per minute each, or 8 liter per minute single flow meter. So we are hoping that yours is not the dual flow meter model, and when testing, the total flow rate of the 2 flow meters did not exceed 8 liters per minute because this results in too low purity despite having all the necessary parts. So, but if that's not the case, the first and the most simple test is to use a pressure gauge to measure the output pressure of the compressor. If you don't have a pressure gauge, you can use one that is designed to test the pressure in vehicle tires. So to test the pressure, you must locate the hose that feeds compressed air to the solenoid valve. Disconnect at the solenoid valve and connect the pressure gauge there. Once you have turned on the power, the compressor will run and the gauge will show the maximum pressure that it is capable of reaching. This will be an indication of how worn the caps and the sleeves are inside the compressor. Every compressor will be equipped with a pressure relief valve. If the compressor is strong enough, it will cause the relief valve to activate, and it can be easily heard. So at this point, the pressure gauge should be showing at least 45 psi or 310 kPa. So if you are successful with this first step, then the next step is to check the solenoid valves and make sure they are working okay. So using a multimeter set into resistance mode, check the resistance of each valve and make sure they correspond to the data sheet. If the valves are okay and you are not getting 25 psi on the output of each sieve bed after connecting a pressure gauge, then looking to the control board could be the next step. So the voltage expected to go to the valves is 12 watts. And if you are getting less than expected, then there's definitely a problem on the board. So ideally swapping with the functional board is the quickest way to troubleshoot if the problem is with the board. Yeah, that's it. Thank you, Maui.
Thank you very much, Tato. So if we have any follow-up questions from the one who sent this question, I can't remember, unfortunately, I didn't keep track of the name. So if you have any follow-up questions or comments on the explanation we just gave you, please, you can come in. And from the other technicians as well, if you have any extra comments, you can add on to that. If not, Jerry, can you please open up the second poll, please?
Absolutely. Thanks, Molly. So this is a generic question. We'd just like to know which brand of oxygen concentrators are you most familiar with? Leave it open for another 5 or 10 seconds. All right, so we have 2 votes on other. A little bit surprising, but there we have it. Thanks.
Thanks, Jerry. All right, so moving on to the next question. How does one test an oxygen concentrator and conclude that it is performing okay? So, Tato, I will push this one to you again.
All right. So oxygen concentrators are medical devices that are designed to supply oxygen up to 95.6% purity, ideally throughout 24 hours without dropping performance, as long as the power is constantly supplied. So an oxygen concentrator can be new or just fixed. And in order to test if the concentrator is performing okay, you need to power up the concentrator. Have the flow meter set at the maximum flow rate. For example, a concentrator rated maximum flow 5 liters per minute. Please make sure it is set to 5 liters per minute when testing. So you need to be careful when you measure the purity on an oxygen concentrator. Make sure you let the concentrator run approximately 5 minutes after powering on. This will allow the oxygen purity to stabilize. And then you have to take note of that purity reading and write it down somewhere. So to be thorough, you should run the concentrator for a minimum of 2 hours and measure the oxygen purity and compare with the first reading that you saved initially. So if the purity has not changed or it has changed a little, then that concentrator can be deployed. Yeah, that's it, Maui. Thanks.
Thank you very much, Tedo, for that explanation. So if we have any questions or additional comments on these questions from the technicians, the floor is open for you to comment in. If we don't have any comments, then I'll ask Jerry to open up our third poll.
Thanks, Molly. So we'd like to know, what is the recommended flow rate when you're testing an oxygen concentrator that's rated at 5 liters per minute? What do you set the flow reader at when testing? All right, just another 5 seconds. All right, ending the poll there. So we have 2 responses saying it should be tested at the full rate of 5 liters per minute. I think this is an interesting question because one thing we've observed in Malawi is that the biomedical engineering training institutions are actually recommending to their students that they test at 2.5 liters per minute. So we thought this was a bit surprising. Thanks, Molly. Sorry, I think I lost my connection there. Did you get the end of the poll?
Yes, Jerry, can you hear me? I think I lost my connection for a few seconds.
I think I lost mine as well. I was basically just recapping the summary of the poll that we had 2 votes suggesting that we test at 5 liters per minute, which is the correct answer. And I also made a comment that some of the biomedical engineering training institutions in Malawi are teaching their students that 2.5 liters per minute is the recommended flow rate for testing, which we think is not right.
All right, thank you. All right, so moving on to our next question. Our local authorities do not know how to dispose of zeolites. Is there a material safety data sheets available? It should be noted that should zeolites come into contact with water, there is an exothermic reaction that can exceed 100 degrees Celsius, and as such can now become a fire hazard. Or can zeolites be regenerated by some method for reuse? Is there any alternative for used zeolites, water filtration or something? So I think we have multiple questions in one question there. So I'll ask Paulina to take this one up.
Okay. Zeolite is a chemical that is used in oxygen concentrators to remove nitrogen from the room air, leaving the oxygen and a few inert gases through a process called pressure swing absorption. Over time, or when introduced to moisture, the zeolite starts to underperform, meaning it can no longer absorb enough nitrogen for the oxygen concentrator to achieve high purity. Hence, the zeolite has to be changed. This brings us to the disposal of zeolite. Since zeolite is used in concentrators, it is not considered hazardous. Most zeolite suppliers do not provide specific instructions on how to dispose of the zeolite. Zeochem and Shintao zeolite suppliers provide safety data sheet, but then they do not provide guidelines on the safe disposal of zeolite and rather encourage you to follow the local regulations. Since you do not have the specific regulations from your local authorities, you might need to come up with your own regulations with the help of your local authorities for the safe disposal of the zeolite. Thank you, Moabi.
Thank you very much, Paulina, for the explanation. So if we have extra questions or follow-up comments on that, you can please come in. I think we also had this question in the previous session. So we hope we have given you the answer that you needed. All right, so if we have no extra comments on that, we'll move on to the next question. I am trying to fix a concentrator, the Devilbiss 515, and upon troubleshooting, I have noted that the circuit board is dead. I do not have another control board from 515, and the only board I have is for the Devilbiss 525, which looks physically the same as a 515 control board, and the connectors also. Any ideas if this board can work? I'll ask George to take this one up, please.
Thank you. Devilbiss has iterated on the models of their concentrators from 515 to 525. 515s are physically big compared to 515s are physically big compared to the 525, and this is because the 515 has larger sieve beds compared to the 525, which are half the size of the 515. Regardless of the differences, these two models share the same size of the control circuit board. The part number printed on the circuit board from both models of the concentrators are the same. They both say 515 AS-132. Even though the number has 515 in it, this doesn't mean that a particular board is meant for just 515 models. It is important to know that the sticker on the sensor has a number that corresponds to the model of the concentrator. For board designed for 515 AKS, it will have a sticker on the sensor written 515 AKS. And the same as for 525 KS, will have a sticker written 525 KS. What differentiates these two boards is the sequencing of the rotary valve. The feeding and the paging time in 515 is longer compared to 525 because of the size of the sieve beds. This makes them not compatible. Thank you.
Thank you very much, George. So if we have any follow-up questions from the other technicians or comments on this question, you can please come in. The floor is open. If we don't have any extra questions on that, I'll ask Jerry to open up the fourth poll of the day.
Thanks, Maui. So we'd like to find out whether people are replacing or repairing boards when they have a dead control circuit board in their concentrator. Leave the poll open for another 5 seconds. All right, closing the poll, and it looks like we have 3 people, 1 person replacing it, and 2 people saying that they would either replace or repair depending on the complexity. Thanks.
Thanks, Jerry. So in case you're just joining us, welcome you to this week's Concentrator Talk. So I would like to just remind you to share with us your contact details in the chat if you haven't done that already, so that we can add you to our mailing list, and then just tell us which country you are joining us as well. So moving on to the next question. In my country, it is difficult to get spare parts for oxygen concentrators, and we frequently use parts from other broken concentrators to fix those that have minor problems. As I am writing to you, I have a Devilbiss 515 that has a worn-out compressor model ZW370. And at my workshop, we do not have a compressor of this model, but we have another compressor model 2660 and 2650. Can I use one of them in my concentrator? George, can you please take this one up?
Thank you, Maui. Compressors are rated in terms of how much pressure they give out and at what flow rate. It is always good to consult the datasheet for guidance. So according to the datasheet for compressor ZW370, the maximum pressure is 102 psi, and the maximum flow rate is 73 liters per minute. By design, 515 is supposed to have a compressor that is capable of supplying 44 psi. That is the reason ZW370 was considered. According to 2660 and 2650 datasheets, both of them can produce more than 44 psi. As such, they can work well in 515. Just to point out that some models of 515 use Thomas 2660 and 2650 compressors. Thank you.
Thank you, George. So if we have any questions or comments on that, we can please raise our hands and then comment in. All right, so moving on with our session. So we'll divert from the questions and now we'll move on to a brief explanation on how to adjust pressure regulators found on different models of concentrators. So Tejo, if you can please give us that explanation.
All right, thank you, Maui. So I will now talk about pressure regulator adjustment on different oxygen concentrators. So just a basic introduction to pressure regulators in case it's your first time hearing about this. A pressure regulator is in an oxygen concentrator is a valve that stabilizes the flow of oxygen to the patient outlet and establishes back pressure on the system. A regulator controls the amount of oxygen pressure in the product tank to a desired value by reducing high pressure or fluctuating pressure from the sieve beds to a controlled lower patient outlet pressure. So a concentrator that has run for over years, chances are high that you will have to replace the regulator because the diaphragm inside gets torn, and this leads to high pressure or pressure fluctuations on patient's outlet, resulting to low oxygen purity. So there are different designs of pressure regulators that you are going to find in an oxygen concentrator. So I think if Amapri, you can go to the next slide. There's so these are the two common ones. So the one on the left is commonly found in a Devilbiss concentrator and requires a triangular tip to adjust. And there's a red toolbox on the next slide that I would advise you to get one for oxygen concentrator repairs. So it has all the necessary tips, the Allen key, the torques, and many more. So the pressure regulator on the right is commonly found in Airsep and Longfal concentrators. So, and to adjust, you need to pull up the knob to unlock and turn clockwise or counterclockwise or anti-clockwise to adjust the pressure and push back the knob to lock it. So moving on. So this is the example for this is the red toolbox I was talking about. If you get this one, you can have access to all the necessary tips for fixing an oxygen concentrator, even adjusting the regulator itself. Yeah. So now I'm going to talk about adjusting pressure regulators on different models that we have worked on, starting with this Airsep 5-liter Newlife Elite. So you need to use the following procedure to adjust the product regulator to 7 psi, which is for the 8 kilopascal. So you need to disconnect the humidifier bottle if you used it, and the tubing from the oxygen outlet, as you can see on the left. Plug the unit to power, and then switch on the unit and allow it to run for 5 minutes in order for the pressure to build up. So you need to remove the side panel and then turn the flow meter adjustment knob counterclockwise until it stops. So at this moment, the flow meter is like widely open. And then you need to pull outward on the regulator knob to unlock it. Turn the regulator knob, or if it has a set screw, you can turn that until the flow meter ball centers on the 5.5 liters per minute line. After you have done that, push back the regulator knob so that you can lock it, and then you can put back the side panel. Yes, that's more about the 5-liter model. And then now I'll talk about the Airsep Newlife Intensity 8 and 10. The setting is the same. So all you need to do is you need to set the pressure regulator to 20 psi or 138 kilopascal. And in order to do that, same steps, you need to disconnect the humidifier bottle and remove the tubing from the oxygen outlet. For this one, you need to remove the side panels and the back panel as well. So connect the unit to power, install an outlet pressure gauge to the outlet of the Newlife intensity, switch on the unit and allow it to run for at least 5 minutes in order for the pressure to build up. Turn the flow meter adjustment knob counterclockwise until it stops. So at this moment, the flow meter is widely open. Pull outward the regulator knob to unlock it. Then turn the regulator knob until the outlet pressure is 20 psi or 138 kilopascal on the pressure gauge. And then after you have done that, push the regulator knob to lock it, and then you can now reconnect the back and the side panels. Yeah, that's it about the intensity 8 and 10. So moving on to the Devilbiss. So for the Devilbiss is quite straightforward. So all you need to do is you need to turn on the unit and set the flow meter at 2 liters per minute. And after you have done that, use the pressure gauge to connect to the patient outlet. And if the pressure gauge reads anything other than 8 to 9 psi with the gauge outlet blocked, then you need to adjust the pressure regulator to get the mentioned readings, the 8 to 9 psi. Yeah, it's quite straightforward. Yeah. So moving on to Respironics. So this is Respironics Everflo, blue in color. So the outlet patient pressure is 5 to 7 psi, and to adjust the regulator, you need to do the following. You need to open the front and the rear cabinet. The product regulator is above the sieve bed. So for this one, you need a T to connect between the regulator and the clear oxygen tubing, as well as to connect the pressure gauge. So after you have done that, power up the unit and allow it to run for at least 2 minutes to stabilize. So set the flow meter to 5 liters per minute. And if you have equipped the concentrator with pediatric flow meters, you can set it at 1 liter per minute, sorry. Yeah. And then adjust the regulator if it is not in the range of 5.25 psi to 5.75 psi by using an Allen key. So the Allen key, you can also find it in the lead toolbox I mentioned. So the adjusting screw is on the end of the regulator. So once the pressure has been achieved, you can reinstall the cabinet. Yeah, that's about it on the Respironics Everflo. And then moving on to the Invacare Perfecto 2. The outlet pressure is anything from 4.5 psi to 5.5 psi. And in order to adjust the regulator, you need to do the following. You need to remove the cabinet, plug in the unit to power and switch it on. Using the access hole located on the control panel, locate the pressure adjustment screw in the center of the pressure regulator on top. While reading pressure using a pressure gauge, connect it to patient outlet. Do one of the following. You need to turn the pressure adjustment screw clockwise in order to increase the output pressure, or turn the pressure adjustment screw counterclockwise to decrease the output pressure. So adjust until the pressure reads a steady 4.5 to 5.5 psi, and then allow the concentrator to run for 10 minutes. So you can retest the pressure by performing the mentioned steps to ensure there is proper operation. And once the pressure is achieved, you can reinstall the cabinet. And finally, on the last model is the Longfal J5. So Longfal concentrators, Yuwells, and other Chinese models, they recommend you to set your pressure anywhere between 45 to 70 kPa. The pressure to set will depend on how your concentrator is performing. So we advise to start with the highest pressure, which is 70 kPa, and work your way down to where you are getting the maximum purity. So the pressure regulator is inside the concentrator under the product tank. So you need to open up the machine to make adjustments. And to adjust the regulator, you need to do the following. As usual, first step, you need to disconnect the humidifier bottle from the patient's outlet, turn on the concentrator, and you need to set the flow meter leading to 2 liters per minute. Connect the pressure gauge to the patient's outlet and make sure the flow meter bore drops down to the bottom after connecting. If the pressure was high, adjust the regulator down to 70 kPa. After making the adjustments, increase the flow back to maximum, let's say 5 liters per minute. Then let the unit run for 10 minutes. Then you can check the purity. If the purity is not going up, reduce the pressure further till you get the maximum purity on the device. Make sure you do not go below 45 kPa when reducing the pressure. So that's it about pressure regulators. I hope it was helpful. Over to you, Mwawi.
Thank you very much, Potato, for that nice explanation. If we have any questions or additional comments from the audience on the explanation that Potato just gave, please, you can come in and ask those questions, if any.
Maui, I'd like to launch a poll actually here, if that's okay.
Yeah, that's fine. Please go ahead.
All right, thanks. So we'd like to find out how frequently people would like to see these 10-minute sessions on specific topics. Weekly, every 2 weeks, or once a month? Leave the poll open for a few seconds. And maybe just a reminder for people who've joined to please put your email addresses and what country you're connecting from in the chat. All right, we've got 3 votes here, maybe another 5 seconds. All right. So 2 people would like to see them weekly and 1 person every 2 weeks. Thank you.
Thank you very much, Jerry. So moving on with our questions. So the next question says, I am a biomedical technician working with a district hospital. We do not have oxygen analyzers. How can we know the purity of oxygen without using oxygen analyzers? So I'll ask George to take this one up, please. George, are you still with us?
Did we lose him? I think if we've lost him, maybe somebody else can take the question.
Yeah. Paulina, would you like to take this one up?
Yes, sure. As we know, oxygen concentrators are medical devices that give out medical oxygen. According to the World Health Organization, medical oxygen has a concentration of above 82%. This can only be confirmed if you have an oxygen analyzer. Even though many concentrators have built-in oxygen sensors with an alarm when the purity goes down below the recommended purity, it is not possible to know the exact purity of oxygen without using an oxygen analyzer. So you will need an oxygen analyzer to check the purities of the machine. Thank you, Moby.
All right, thanks, Paulina. George, do you have anything? I see you're back. Okay, I think we can move on to our next question. So the next question says, I just wanted to know if I can refill the cylinders using an oxygen concentrator. So Paulina, if you take this one up again, please.
No. Cylinders are filled at a high pressure. Concentrators are small machines that gives out oxygen at a low pressure. As such, it is not possible to fill cylinders with only the concentrator. You will need an oxygen refill machine, which has a compressor that is used to supply pressurized oxygen to fill the cylinders. These kind of cylinders are very small and mostly used in emergency compared to traditional ones. In some models like the Invacare home fill machines, it takes over an hour to refill the cylinder. Just to point out that oxygen refill machines are 3 times the cost of an oxygen concentrators. Thank you, Moby. I think I've answered the question.
All right, thank you very much, Paulina. If we have questions from the audience or any additional comments from the other technicians, you can please come in. Yes, I see we have a hand from Ampri.
Yes, I would just like to add that with the Devilbiss concentrators, you can actually refill a concentrator. There's a specific cable that you need, and it will fill, as Paulina said, a very small cylinder, and it will take pretty much the whole day because of the difference in pressures. But it is designed for perhaps patients in hard to reach areas that need something when they're traveling or visiting a hospital. It's not meant to be used to fill cylinders for like multiple patients. It will really only fill 1 a day, but that is an option with the Devilbiss concentrators if you purchase a couple of the different attachments that go along with it. Thank you, Mom.
All right, thank you very much. Okay, so we have another poll. So Jerry, can you please open that one up?
Thanks, Molly. So we'd like to find out where people are connecting from today. Seems like we have a predominantly African audience. All right, I'll close the poll there. So we have 3 people connecting from Africa. Thank you.
Thank you very much, Jerry. All right, so moving on to our next question. I read from the manual, they said an oxygen concentrator is not supposed to be connected to the extension. They did not explain why. What could be the reason? I'll ask Mteto to take this one up, please.
Thanks, Maui. So on this one, every wire that carries the electricity has a resistance, and this resistance causes a voltage drop. So the longer the wire, the greater the resistance, and this will also affect the voltage. So if you have a very long extension cable, the voltage gets dropped in the cable, and when this happens, the performance of the concentrator gets affected, as the device is supposed to run in a specific range of voltage supply. So the concentrator the concentrators have a specific voltage range where they can operate effectively. So anything below this voltage will have a negative effect on the concentrator. So for instance, an Airsep light rated 120 watts or 230 watts, the purity is affected when you have extreme voltages, as you can see on the table there. And then the second problem with extension cords is that they have a low current rating. So if you are connecting multiple concentrators on one extension cord, you end up either blowing the fuse or burning the extension cord wire. Yeah, that's it, Moi. Thanks.
Thank you very much, Tato. So if we have some comments or extra questions on that, you can please come in and comment. All right, if we don't have any questions or comments on that, we'll move on to our final question of the day. So the question says, can a weak compressor be rebuilt? And if so, what parts are required? So this question came from Augustus and Tato. If you please take that one up. Tato.
Oh, sorry, my mic was muted.
I see.
Yeah. So this is the question about weak compressor, right?
Yeah.
Okay. So yes, it can, and we have a nice video on the Oxygen Alliance website that steps you through the whole process. So a weak compressor typically means the cylinder sleeves or capsules have worn out. That is the part that can be rebuilt. So the whole process takes less than an hour. It may require some specific tools, such as torques, more like the screwdriver, the toolbox I showed earlier, the red one. So you need like torques, Allen keys, depending on the model of the compressor itself. But these can usually be purchased like locally, even here. So we are pasting the link in the chat to the video of the compressor itself.
All right.
Yeah.
Thanks, Tato. Augustus, I think if you want a very detailed explanation, then as Tato said, we have a link in the chat box. You can just follow that one up. It's our Oxygen Alliance website, and you'll find the video on how to service the compressor there. So you should be good to go from there. All right. So if there are no further questions, I would like to thank everyone for joining us today on this week's Concentrator Talk. Remember that we will be meeting here again at the same time next week. And if you have any questions, you can send them to us in advance at info@oxygenalliance.org, and we'll do our best to answer them. I'm not sure if you have anything to add on before we finish. Jerry, Amapri.
Nothing from me. Thanks for joining, everyone.
Same here. Just if you aren't getting our emails, if you don't mind putting your email in the chat, we do like to send reminders and summaries, as I hope you've all had a chance to look at our YouTube channel as well, where you can see these as well as any other videos that we've posted. There are summary PDFs on the auctionalliance.org website, which have the specific question time on it, so you don't have to watch the whole video. But please do share your email with us or give us any other thoughts for how we can make this more valuable for you all listening here today. But thank you very much.
All right, thank you. Have a good week, everyone.
Bye.
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 Bye, everybody.
Thank you, everyone. Goodbye.